All right. So again, I just want to start with any questions that anybody has, and if not, then we'll get started with talking about these two pictures that I found, these two diagrams, which I thought were incredibly useful. It's like, man, this is such a simple way of explaining the difference between. So this is a regular while loop right here. So just a regular while loop, and then this is a do while loop. So we had talked about these a little bit, and of course we had the whole video on looping and the PowerPoint presentation. Hopefully everybody has at least a good grasp on looping. But I thought that this visual was very neat for the difference between these two loops. So if we look at a regular while loop, we first test the expression. And if that test expression is false, we never execute the loop body. We just exit the loop. If it's true, then we execute the loop body, and then we loop back to testing the expression, and then we keep doing that as many times as necessary until it's false, then we leave. Now that is similar but different than the do while. It's actually backwards. Our do while is backwards. So for the do while, we execute the loop body first, and then we test the expression. And if that expression is true, we actually loop back to the loop body and execute the loop body again. So the difference, a big difference here is a while loop. If the expression is initially false, you will never execute the loop body. In a do while, even if the expression is false, you go in, you execute the loop body, then you exit immediately. So you're guaranteed to do at least one iteration of the loop.
What would be a use case for a do while loop versus a while loop?
Oh, good question. I've got a good example. Let me say before I put your hopes too high, I got an example. Okay, I think it's a pretty good one. But to answer your question, I would say input validation, right? We want to get input from the user, and then we can test the expression and say, is that expression invalid? And if it's true, we ask the user to try again, and we keep doing that, keep them in the loop.
Gotcha.
That's just one of many uses, but to answer a little bit more thoroughly, 90% of your loops will be while loops, while versus do while, and 10%, and I'm being generous with 10% of your loops being do while loops. You know, when we're talking about real practical uses, not me saying, hey, code a do while that does this because that's what I want you to learn how to do, right? Okay. Any questions about while versus do while? Because we're going to be spending a lot of time talking about this today. All right. Well, then we have our first bit of work that I want us to do. In Discord, just in case you guys want it, I have uploaded the document for this, and we're going to do this together. So this sheet says convert the following while to an equivalent for loop. So first of all, what type of loop is this?
A while loop?
It is a while loop. There was some terminology we were talking about, like an end of file loop, an event driven loop, blah, blah, blah. There's a bunch of different words that we use to describe this stuff.
Was it a count controlled loop?
Count controlled loop. Yep, that's exactly what I'm looking for. So with a count controlled loop, what is our structure that we want to use if we possibly can? And when I say structure, I mean like, should we use a do while loop? Should we use a while loop? Should we use a for loop?
A for loop.
Yeah, we do want to use a for loop. I agree. And it's because it gives us the convenience of putting all of the parts of our loop in one spot. We can't possibly forget any of the parts of the loop. And it's just really dang convenient for count controlled loops, right? Okay, so that's the purpose of this little group works here that we're doing is we want you to see that this is how you would write this in a while loop if you only knew how to do while loops, but converting it to a for loop is super simple. Okay? So let me pause this. Okay, so let's start that. So I'm just going to write a little nothing, apparently. Write a little line right here, and then we'll start over here. So you want to start this with a for parenthesis. Okay. Now what's
int
the
I.
int I? Okay. Well, let me change that int I because I agree that that's how we would normally write a for loop, but we do have a variable here that so when we're
Okay,
translating
we
this.
can use count then if you want.
Okay, yeah. It's not super important, but again, when we're talking about an assignment like this, if this was on the exam, for example, you would lose points just for renaming the variable. So don't fall for that. So int count equals what? 0?
1.
Oh, 1. Good.
That's why I didn't think it would matter because we're reinitializing the variable. Yeah.
Yeah, no, technically, you're absolutely right. But when we say convert the following while loop to an equivalent for loop, I would argue, well, it is equivalent. It does functionally the same thing. I don't know. We could argue about it. You know what I mean?
So it's not true equality. No triple equal sign here.
Yeah, that's a fair statement. Okay.
And they,
So this first part is our initializing the LCV. And now the second part is what?
so if I is less than or equal to 10,
So if count is
count,
less than or
sorry.
equal
I'm
to
just so
10.
used to I as the default, sorry.
No problem. I completely understand.
Semicolon, I plus plus. God damn it, sorry. Count plus plus.
No problem. Thank you for participating in that. Now you got all three sections and you put them in the exact order that we wanted them. So what is this first part? What do we call this?
Initialize LCV.
Initializing the LCV. We got to get that loop control variable established. We got to set it to an initial value, and this does that. Semicolon. Okay, what's the second part of the for loop?
The test expression.
Yes, it's our loop test. So this is what determines if we go into the loop or not, right? Okay, now what about this last part?
Modify.
Modify the LCV. Perfect. And now everything inside of the loop, we would call that what?
The body.
Yep, the loop body. Okay, so we got the full anatomy of a loop and we understand that. Excellent. Okay, so let me just write up here. I want to make sure that I know it just says rewrite the loop, but I'm going to redeclare total up here to make sure that it's clear that that's created. And then so now inside of the loop, now we just need the loop body. That's the last piece to this that we need to do. So in the loop body, what would we put?
You could keep the total equals total plus count the same.
I agree.
And then count plus plus.
Isn't that no longer necessary because it's in the
Oh, that's right.
modify?
Agreed.
Nice.
Now, and if you did have this, was a good example. Thank you, Andrew. Thank you. Since you modify the LCV here in the for loop, and then if you do it here, what's going to happen is we're going to go right here. We're going to execute this line of code. It's going to take count from 1 to 2, and then we're going to go up, and then it's going to go from 2 to 3, and then we're going to go in. So then you're skipping an iteration if you're modifying the LCV twice, right?
And is that how you would do it if you wanted to skip an iteration?
Oh yeah, well you could, or you could just put count equals count plus 2.
Yeah, that's
right
what I
here.
was wondering. If
Yeah, I mean that's what I would do up here, because that just makes more sense to keep your modified LCV in one spot. But let's just say hypothetically there was a certain number, like you had a function that determined if this was a prime number or something, right? And if it's a prime number, you want to go up by 2 instead. Well, you could just say like if is prime count plus plus, just so that you are skipping 1.
Gotcha.
Okay, so we got our total, and the total is blah. This is perfect as it is, actually. We're already done. So rewriting this loop, if we replaced it with this for loop, we would have the exact same output. And this for loop is better structured and a lot easier to read. So we like it more. Okay, now the next one that we have is this do while paper here. I'm going to pause this really quick. All right, so for this one, code a properly structured count-controlled loop which calculates the sum of all even numbers and the product of all odd numbers, 1 to 12 inclusive. So I'm just gonna underline this because this is very important to me that it's 1 to 12 inclusive. So 1 to 12 inclusive. So that means we need to start at 1, whatever our count control is, and we need to go up to and including 12. So this is a count controlled loop, so I'm gonna do a for int I. I'll do the I thing this time, Andrew.
Thank you.
You're welcome.
And do you have to set it equal to 1 here?
Yes, because if you started at 0, well, yeah, I think you would. Only because, and I didn't leave enough room for this, but let me declare these two here, up here. We would need an int sum, and we would need an int product. And I'm going to set product equal to 1, because if we're doing the product of all even numbers, oh, and we have to set sum equal to 0, excuse me. So int sum equals 0, int product equals 1. We just have to set these up because if we're going to be multiplying a whole bunch of numbers through, if we start at 0, 0 times anything is 0, we'll just end up with 0 at the end, right?
Yep.
Okay. And so if we also started at 0 and we took the product of that, well, I guess odd numbers, so I guess we wouldn't do that, right? You know what? You're right. You could start at 0. And it wouldn't change anything. But we would do an extra loop through that we didn't need to do because 0 is pointless. So I'm going to give you that as the reason why we're not going to do that.
Okay.
Okay. So while I is less than or equal to 12, because I would have normally done just less than 12, but less than or equal to 12 because it's inclusive. We need to include 12. So we need to do the loop where I is 12. and then another semicolon. Now, what is my modify LCV for this one? Just increment. Now, it calculates the sum of all even numbers and the product of all odd numbers. So we need to make a decision. So we'll write an if statement here. And we'll say, well, if I, and to determine if it's even, we're going to have to mod 2 equals 0. If this is true, then we have an even number. And then we do the sum. So this is an even number. So we say sum equals sum plus I. So we just add I to all of our sums that we have so far. Now, if something is not even, then we can say else. Else, it's got to be odd. And if it's odd, we take the product of all odd numbers. So we say product equals product times I. So if we go through this loop really quick, sum equals 0. Product gets 1. I gets 1. Then we do our loop test, and we say, is 1 less than or equal to 12? Well, that's true. If 1 mod 2 equals 0, well, it doesn't. It equals 1. So we go into the else, and we say product equals product, which is 1, equals 1 times 1. So we end up with 1 in product. Okay, now we're at the bottom of the loop here. We go back to the top. We modify our LCV. So I goes from 1 to 2. Now is 2 less than or equal to 12? That's true. So if 2 mod 2 equals 0, well, it does. 2 divided by 2 is 1 with no remainder. So sum equals sum plus I. So sum is 0 right now. So 0 plus 2 equals 2. And then we go around the else block. And then we go back up and modify our LCV. So 2 turns to 3. And now is 3 less than or equal to 12? Still true. 3 mod 2 equals 1, so it does not equal 0. So we go into the else block. Product equals product times I. So 1 times I, which is 3. So product 3 times 1 is 3. And there we go. Back to the top of the loop. We modify I, so I becomes 4. And we keep doing that until 12. When 11 turns to 12, keep in mind this is less than or equal to 12, so we go inside the loop again. When we are finished with that iteration, I goes to 13. Now when I becomes 13, 13 is not less than or equal to 12. So we did successfully calculate the sum of all even numbers and the product of all odd numbers from 1 to 12 inclusively. Does that make sense? Did anybody have anything else that they would want to check, or?
I don't follow the product one. I don't see how, like, if we keep going, it would get them all.
Oh, what do you mean? Do you mean like you don't think that we're actually doing odd, we're not getting odd numbers here, or?
No, I feel like we wouldn't be multiplying all the ones we wanted. I feel like it would, like, jump and go too high or something, but maybe I'm not following it correctly.
Oh, are you thinking just the fact that in the product of all odd numbers, so all odd numbers from 1 to 12 is 1, 3, 5, 7, 9, and 11, right?
Yep.
So that first, let's just say, we'll just completely skip out all other loop iterations. But we agree that these numbers for I will go through, right?
Yep.
So if product starts at 1, what we're essentially saying is 1 times 1, which gives us 1, times 3, which gives us 3. So this is already correct, right? Because the product of 1 and 3 is 3. And then the next one we would do is the product of 3 and 5, which would give us 15. Oh boy, I'm doing math here, huh? Okay, so, and then 15 times 7, which gives us 105. So these two products together gives us 105.
I was interpreting it wrong. I thought like you wanted it to be like in the wording of the problem at the top. I thought you wanted it to be like 1 times 3, 3 times 5, 5 times 7, 7 times 9. That kind of idea. 9 times 11.
Oh. So you thought just those two numbers stored in product. No. We want the product of all the numbers. So really what this equates out to, and mathematically it makes sense, is 1 times 3 times 5 times
Yes.
7.
Okay.
So that's the product of all numbers from 1 to 12. All odd numbers.
Got it.
Does that
Okay.
clear it
Yeah,
up a little bit?
just misunderstood it. Okay.
Yeah, no problem. I know that wording can be a big part of it. That's why we're doing these, so that, when the quiz comes and the exam comes, kind of get that wording down a little bit better. The programming is easy. The English is hard. Okay, so moving on to the next one, but not really. Okay. So I'll start us off with this one, because like I said, there's definitely more than one way to do this one. So I'll start us off, and then hopefully we'll have some other differing opinions on how to do this. So code a properly structured count-controlled loop which prints every third integer between 6 and 777 inclusive, one value to a line. So, okay, a few things here. A properly structured count-controlled loop. So count-controlled loop, it doesn't tell me that I have to use any particular structure. So in the count-controlled loop, immediately I think, okay, this is a for loop. This is a for loop in the making. So I'm going to write my for int I. Because I don't have a variable name, I'm just going to stick with I right now. That is my LCV. Equals 6, because we need to start at 6, because between 6 and 777 inclusive. So I need to make sure that I hit 777 as well. Now, while I is less than or equal to 777, less than or equal to because it's inclusive. If it said exclusive, I would have just done less than 777. Okay. Now we do another semicolon, and we need to modify the LCV. Now this says a loop which prints every third integer. Now in my head, I'm thinking, okay, why would I want to loop through, like do an I++? I'm not going to do an I++ because that's going to go up by 1, and then I'll have to do some check to say, like, is this the third, and blah, blah, blah. That's a lot of work. So instead, all I'm going to do is I'm going to say, well, I plus equals 3. Now, remember, plus equals is shorthand for I equals I plus 3. So if you wrote that, that's the exact same thing. So we're saying starting at 6, and then we'll modify by adding 3 to it, which allows us to print every third integer. So now, since we're only getting every third integer, we can just do cout I, and then an end line.
But wouldn't that print out 6?
That would.
Inclusive.
Yeah. Inclusive.
But I thought you meant inclusive, like the number. Wouldn't the third integer be 9 in this case?
If you want to argue that, and like, so I would say, okay, yeah, maybe the wording is a little ambiguous there. We could fix that by just, right?
Yeah, because that's what I have what you wrote, but I was just confused by the wording there.
Oh, so you started it at 9 and then did like this, or
Yep.
that's fine. You understood the concept behind that. I mean, when I read this, I see 6 to 177 inclusive, and since it says inclusive, that means we start at 6. Prints every third integer, though. I get that. Yep.
But if 777 isn't the third integer, then it wouldn't be printed.
Oh, right. And to be frank with you, I don't care about that because that's not what the instructions said. The instructions didn't say like specify 777 has to be printed. I'm not sure if 777 is in threes
It will be
from
'cause it's
6.
divisible by 3.
It what?
It will be. It's divisible by 3, and 6 is divisible by 3. So
There you go. The man has got the answer. It's perfect. Okay. Did anybody have anything a little different than this, maybe, that they want to talk about? Okay. Now, and just to verify here, everybody understands how we made this for loop, why we did every single piece, including initializing the LCV to 6, our loop test, I less than or equal to 777, why the less than or equal to is there, our modify LCV, nobody is confused by the shorthand, I plus equals 3, right? And I know everybody knows how to see out something by now. So, no questions there. All right, then let's move to the last little problem that we have here. Let me resume this. And the first thing that I want to talk about really quick, outside of this, is just the syntax difference between a while and a do while. You'll notice in the while loop there is no semicolon here. So I just want to point out, in our normal do while loop, we will have a do, and then our loop body goes here between the curly braces. And then right here, right next to our last curly brace, we actually write our, I almost wrote whale, while, and then some expression here. And then we put a semicolon at the end of this. This is the thing that trips a lot of people up when writing a do while, is don't forget this semicolon here. It's tricky because no other loops have a semicolon in there. Well, besides inside that for loop, but I think that this is tricky at least. Okay. So convert this loop. Okay, so what we can do is, well, we don't, this is basically like our priming read right here, right? We're asking the user to do something, and then while that's true, we're blah, blah, blah. Okay, well, instead, what we're going to do is we are going to have a do. Okay, and let's see here. Our while is probably going to be the same thing as this. So if the user didn't choose N or Y, so we can say while choice does not equal N, and choice does not equal Y, semicolon. So whatever we do in here, we will loop back to the top if they did not pick N or Y. So what we can do is one of two things really. Let me just start with the main bulk of this. So we would see out just like we do here, right here. Enter Y or N. N line. And then we see in our choice.
Would this be how you test the user's like data to like if you don't want a certain value to just keep looping back to the CN if they keep putting in invalid data?
Yeah, no, absolutely. That's probably the number one use of a do while loop that I know of is validating some sort of input.
Okay. Yeah.
Because you need to get this input at least once from the user, right? And if
Yep.
only if they do it wrong, do you want to repeat it? So a do
Yep.
while,
Yep.
perfect for it. Okay, so this already kind of works. It's not exactly what we have here, but let's fix that here in a second. So what's going to happen is we go into the do, we say enter Y or N, and then C in choice. Now, if the user inputs a Z, we will go down to the while and we'll say, does choice not equal N? Well, it doesn't. So that's true. Choice does not equal Y. Well, that's true. So true and true is true. So we loop back to the top of our do while loop and then we ask them to enter Y or N and then we get their choice again. And we loop this until they enter an N, let's just say. Choice does not equal N. Well, that's false because it is N. So a false and we short circuit, we exit the loop. Now we have a valid choice from the user. Now the only thing that we're really missing here is telling the user that it's invalid. And we can remedy that really quick within this loop by just saying if, and all of this right here, choice does not equal N, and choice does not equal Y. Excuse me. My writing is getting really bad. Then we see out choice is invalid. And L. And we're done. So if the user inputs a Z here on the right hand side, we see out please enter Y or N. They input a Z. If this would be true, so we would see out Z is invalid, while this would end up being true. So we'd go back to the top and we'd ask them to enter Y or N. And then they would do it again. And if they did it wrong again, we would output that choice is invalid. Our while would still be true. So we'd go back to the top and yada, yada, yada. This keeps happening. Now, if we did it over here, let's just make sure it's the exact same thing, right? So if we see out enter Y or N, we see in choice, we do Z. While choice does not equal N and choice does not equal Y, well, that's true because Z is not equal to either of those things. So we see out the choice is invalid, enter Y or N, and then we get another choice. It's the exact same logic. Well, there's one major difference, and that major difference has to do with the fact that we're writing this out twice, right? We're writing out our test twice. And that's not great. I don't really want to write that twice. So instead, what I'm going to do is just going to improve this a little bit. And just for the record, this would have been perfectly fine to do. Perfectly fine to do. Or you could have done it this other way, which is up here. I'm just going to declare a bool is invalid. And then we say is invalid. We could have a function that does this or whatever, but we can also just say is invalid gets choice not equal to n and choice not equal to y. And then a semicolon there. So this is getting a little messy, but now I can simplify this by saying is invalid. So if this is invalid, so this will evaluate to a Boolean expression, right? So if we input z, this expression evaluates to true. So is invalid equals true. So we say if is invalid, which is true. So we go in and we execute this statement, outputting that choice is invalid. And then we say while is invalid, we loop back to the top and redo it. And now we've taken our expression that determines if it's valid or invalid and put it in one place.
If you were to initialize the is valid or is invalid variable within the body of the do, would the while loop or the while have access to it there?
It would actually, yes. It would, but it would also get destroyed with each iteration of the loop. So you remember how we talked about how the compiler will sometimes optimize that stuff by hoisting it up above the loop? Well, I just preemptively did it.
Gotcha.
So because it is inefficient for you to repeatedly with every single loop ask for more memory, right?
Yep, that makes sense.
So just for the record, though, either way would have been absolutely correct here. Would have accepted both answers. Not a problem if you wanted to if you wanted to put the bool is valid down here. Yes, you would have access to it here in the loop test. Not a problem with that. Okay. Any questions on this last one? All right. Let me pull up my quick do while example that I started here. I went ahead and just coded it up, but I wanted to have something that was a little bit, I mean, you know, at least sort of a real world example here. So what I have is I want the user to input a file and I want to keep a file name. I want to open that file to read contents from it. But if they send me something that's not a file, the file doesn't exist, then I want them to try again, right? It's a very, very normal use case for some things like a project or something like that, right? Now, what I can do, and this is just very simple, and we'll work on improving it here. So we declare our DN and we declare a string variable just so that we can get input from the user and try to open that file. So we can do our do and then see out, please enter a valid file name. Okay. So we got to enter a valid file name, something that we can actually open. We get that C in file, and then we try to open the file. And do you remember how when we try to open a file, we can say if not dn, and then that tells us that that file does not exist, right? Because dn will evaluate to false if that file doesn't exist, if that file was not successfully opened, right? Everybody's on the same page with that?
Yep.
Okay. So if that evaluates to false, then we can say, well, while not dn, so that false turns into a true. We loop back to the top and we ask the person to enter another valid file name. And we can just repeatedly do this. So if I really yep.
I got a question. I did the lab already and I submitted it, and I see a place where I could have used that. Will I get points docked off for not?
Did it tell you to specifically use that?
I don't think it specifically said it, but I'm just thinking if we had a week, I wonder if you would have wanted us to do that.
Uh, if you want to get a more specific answer, we'll have to take a look. But
Okay.
I doubt it.
Okay. All right.
So,
I was just checking.
but we can look. We can look just to make sure.
Okay.
So I went ahead and created a test.txt file in here so that we can use that as our example. Remember how we can do that is you can just right click on the solution up here and then go to open folder in File Explorer. Real easy way to just open where your project is. So, okay, if I run this now, please enter a valid file name. No. Well, we looped back up. Still no. Sorry, I put a space in there, so technically that loop ran twice. So enter valid. Nope. Okay, now I give up. I'm going to try to enter test. No, that's not right. We need test.txt. And now the file was found. So we exited here. File was found. And then do our system pause. And that's it. That's all that the program does. And like, this works pretty well, right? I hope everybody agrees. It does the job. It's not very user friendly. Like we could tell the user, hey, I couldn't find this file, right? File not found. But does anybody have any questions or comments before we make that improvement? No, everybody's good. Okay. See that was a trick. I never closed my file. No, I'm just kidding. I just now realized that. So, so after we do our dn.open, what we can do is just if not dn down here, and then say cout in file doesn't exist. Please. Let's just say it just does not exist, and then we'll just say please enter a valid file name. That makes sense, right? So please enter a valid file name. Test. Test doesn't exist. Please enter a valid file name. Now this is getting pretty user friendly, right?
Yeah.
File found. Awesome. I know everybody's not quite as excited as I am, but
I'm excited
Yes.
because I've been hating not having a loop to use in my project. I'm like, this is stupid. I'm just telling the user for no reason that it's not valid.
and then we're
Keeps going.
exiting. Yeah.
Yeah.
Okay, if I could get a couple woos from you for all these examples, then that'll be great. Now-
I think it would have been more exciting if you put 404 error.
Just 404.
It's my favorite.
Oh, okay. So that was for this next part. I put in Blackboard. So I'm just letting you guys know to open up Blackboard right now. Go to the videos. Go to the live lecture folder, and there is an upload. It's the only way that I can figure out. Zipping up workspaces and all that stuff. Like I can't upload it to Discord because it thinks that I'm trying to infect everybody on the server. And I can't do it through Google Drive for the exact same reason. This is the problem with sharing workspaces with you guys. But in there, we have 2 workspaces. And I've got to get organized here. And we'll start with this one. This one is the coolest one, I think, which is a Sentinel. So we're going to learn a little bit about Sentinel loops. So you know how we had event-driven loops, which we had 3 that fall under the event-driven loop category. We have our end-of-file loop. We have our Sentinel loop. And then we also have our... Oh man, I'm blanking here. Flag controlled loop. That's right. flag controlled loop. So in this one, we're going to look at a sentinel loop. A sentinel controlled loop is a loop that is controlled by a sentinel value. So in this case here, we have a sentinel value set as Q. So what that means is basically we're trying to, which we'll read through this whole thing, and if anybody's having trouble getting the files, just stop me. But other than that, I'm just going to keep going through this while everybody's getting set up. So basically what we're trying to say is the user is going to input a Q when they want to quit the program. That is our sentinel value. We're going to keep looping, and we'll keep doing the body of this application until we get the sentinel value. This sentinel value is what tells us that it's time for us to exit now. Okay? So we declared that as a constant because that's not going to change. And then we have a few functions that are already all set up for us. We just have to use them. And we can go over what they do and stuff like that. But it's actually kind of cool that we don't know what we're doing. We're just going to kind of paint by numbers and then see what happens, okay? I've never ran this program even, so I don't know what it does. So let's find out. So we have a char choice. This is the user's choice. That makes sense. Using the functions declared below, code a loop which iterates until a user enters sentinel value to quit below. If the user chooses A, you should call print characters 26. Okay. If the user chooses B, you should call print characters 52. If the user enters Q, the loop should stop iterating and you should call print summary and exit the program. If the user enters anything other than A, B, or Q, you should call print error message with the choice. All right. Pretty simple. I mean, I have no clue what's going on, but I can follow those directions, right? Anybody having any troubles? Want me to slow down before I start filling out this?
I'm all set.
All right. Good. Good. So step 1, priming read. So let's see here. Don't we have this. This is a function, get choice, and it returns a character. So this must get us the choice that we want. So we want to set choice equal to get choice because this function is gonna return our user choice. I'm kind of just assuming based on that function prototype. Okay, so that's our priming read. So we got our choice, and now we have a loop test. While what? While choice does not equal our sentinel value. So choice is a character, sentinel value is a character, it's Q. So what we're saying is while the user did not enter a Q, we want to do this loop. Okay, that seems reasonable, that seems good. Now step 3, we got the loop body. So in the loop body, we were asked to do this part basically. If the user enters an A, you should call print characters. If the user enters a B, you should call print characters with the different argument. And if the user enters anything other than that, you should call print error message. Okay, so we got a multi-alternative if statement, definitely. So if choice equals A, then do something. Else if choice equals B, we'll do something else. And if they put anything else, we want to print our error message. So let's just come down here and just write an else, blah, just like that. Okay, so if the user enters A, you should call print characters. So print characters 26. Okay. Now, if the user chooses B, you should call print characters 52. Okay. can do that. And if the user enters anything else, print error message choice. So that's in our else block down here. So if we're inside this while loop, we know that they didn't input a Q, because otherwise we wouldn't be in the loop executing the loop body. And then we say, well, if it's an A, do this. If it's a B, do that. Else, it's obviously an invalid choice, so we need to print our error message. All right, looking good. And our last step is to modify the LCV. And as everybody here knows, modifying the LCV in a loop is the same thing, when we're dealing with an event-driven loop, is the same thing as just redoing the priming read. So let's redo the priming read. So we're going to get another choice from the user, and then we go back to the top. So if the second time the user enters a Q, Q will be stored here, and we'll go while choice does not equal Q, which it does. So this becomes false, and then we exit the loop. So okay, this all seems reasonable. Seems like it's working. Fill in the call to print summary. All right, so now we can just do print summary. And it takes nothing else. And then here's all of our functions that were created for us, which is so nice that we don't have to do, right?
Definitely.
Okay. Well, let's just see if we made any mistakes. I'm also excited to see what this does. Okay. A to print the lowercase letters. Oh, that's cool. Okay. Yep. Yep, it did that. Now what happens if I do a lowercase a out of curiosity? Oh, it does it anyway. Let's take a look at how they did that really quick. So print error message, just a whole bunch of new lines. Choice is not a valid choice. We should test that really quick too. Z. Z is not a valid choice. Okay. And then we go back to the menu. Now if we come down here, get choice. Okay, here. So this is a function that calls another function. So it's important to note this can happen, right? So we have a variable choice. We print the menu, and then we see out, please enter your selection. We see in that choice, and then we clear the screen. And then we use to upper choice. Okay. So choice is always going to be stored as an uppercase character, and then it's returned.
Is that a homemade library, or is that or homemade function, or is that a library, the two upper?
It's in the C type library. CC type, excuse me. I believe that this one has two upper, two lower. Really quick, I just want to curious. Yep. So it has two upper, two lower. You pass a character, it'll give you the uppercase version of it. If you pass it the uppercase version, it'll just return the same thing to you. So that's nifty. That allows us to not care about case sensitivity, right? So I can do an A, a lowercase a. It'll convert it to a capital A, and our comparison will work. And it'll print everything, all of the lowercase characters. And if we do a B, okay, it does all the lowercase, then it gets to Z, and then it does the uppercase characters. Pretty neat. Now let's try our Q for quitting. Yeah. It works pretty well. Anybody having trouble getting that working? All right, I'm going to assume everybody got that working. And the most important thing to understand out of this is everybody understands what a sentinel controlled loop is. So we're just waiting for an event to happen, and that event is we're looking for a particular value to come up. All right, so now that segues really well into our second Sentinel example, which is the Sentinel loop workspace, which should be zipped up in there with everything else. So with this one, we have a Sentinel value that's set to a -1. I'm sure plenty of people must have seen, some really old software application where it says like enter -1 to exit or something like that, right? Everybody's got to have one story like that. So here our Sentinel value is -1. Like I said, we have this calc average function declared here, this function prototype. We have the in file, the input file name, the num, which is the value read from the file, the sum, total of all values from the file, count, the number of values read from the file, and the average of all the values read in. Okay. Input the name of the input file. So we associate the input in the in file with the file as specified by the user. So we're just doing an open. You can kind of just ignore this .c string. That's an old thing that we don't worry about anymore. But if you ever do see it, it just has to do with old stuff that doesn't matter anymore. Okay. But you can also just leave it there. It won't hurt anything. Okay. So if not in file, the file you specified was not found. Sure. This is the way that you hate it, Jacob. It'll just exit. So if the file was found, we'll want to do our priming read. Okay, well our priming read is just we're just gonna read a number from the file. Oh, really quick before I forget. So if you right click on the solution like we did before, open file, open folder in Explorer, you'll have this. And everybody should have int2.dat in there. If you take that, drag that, and drop that into Visual Studio, it will open up the file here, which is nice that we can just look at it like this. So if we look at this really quick, I can see that the Sentinel value is -1. So basically, we're going to loop test while we don't have the Sentinel value. So if I just do a really quick look for -1, I see there is the -1. So this is the Sentinel value that we're looking for. So, and it is a very normal thing actually, where you want to process a file and you're looking for something that signifies that you're at the end of the file. You don't necessarily want to consume the whole thing, but you're looking out for something that says, all right, you're done with whatever you were processing. So in this case, it's this -1. So if we go down here, we should be calculating the sum and a count of how many numbers there are until we get to the -1. And then we're going to calculate that average and we're going to output that. Okay, so step 1, priming read. Cin num. That's it. So we know that the file exists because we're in the else path here. And so since that file exists, let's read that first value, our priming read. And then now our loop test, I mean, sort of just like in the last one, we're just going to say, while num does not equal Sentinel value. So if that number that we just read from the file is the -1, then we just exit. We're done. Now, step 3, loop body. We're going to calculate the running total and count how many values are read in. Okay. So we have a sum and a count. So sum plus equals, because remember we're just going to add to the sum, plus equals num, and count plus plus. that starts at 0. Sum starts at 0. Those are good. So we'll add whatever's in num to sum, and we'll increment count by 1. Next, modify the LCV. So let's take our CN statement here. Oh, I'm just now realizing what I did wrong here. CN. I'm getting this from the keyboard. Why am I getting this from the keyboard? No. We've got to get this from the file, right? So there. If you had CN, make sure to change that to in file so that we're reading the number from the file. Okay, so we have all 4 pieces of our loop. We have our priming read, our loop test, our loop body, and modifying the LCV. And as a quick test, yes, our priming read is the same as our modify LCV. So we are good. So when we're done, when we find our sentinel value, we will exit the loop and we will come down here where we will call calc average, sum, and count. And we'll store that value in average. Well, really quick, let's just put a marker here that we'll come back here. Calc average I'm not sure if I did this in my local, but if it's like this in the zip up, make sure that you change this to calc average, because otherwise this will not run. Is it like that in everybody else's, or was that just me?
Yeah, it was like that.
Okay, yep. Make sure to change that. So we're calling calc average, which we pass in total and count num, and all it does is just takes total, cast it to a float, count num, cast it to a float, and then divides them. And then it returns that. That's the average. Total divided by count. Okay, that makes sense. And average is a float itself. Okay, so this is all good. Everything's kosher here. So fill in the function call to display summary below. I don't think that we're doing that. I'm pretty sure that this is the display summary, so I'm just going to delete that comment. Just for the record, that doesn't work with all the homework assignments. If you don't like a comment, you don't just delete it and then not do it. Okay, but there are privileges that come with experience. Okay, so we're gonna output the count values were read from the file, and we're keeping count here. From file input file name. Okay, and the average of those values is average. This makes sense. This should work. So let's save this and let's run this.
By the way, don't have system close. Or system pause, sorry.
Oh, thank you. I was going to be very disappointed.
Saw that there and I'm like, well.
So don't forget to put a pause so that not everybody's not disappointed like I would have been. Okay, so enter the name of the file. No. The file name you specified, no, was not found. Okay. Jacob, I know what you're saying right now, and I want to say, no, I agree. We should fix this up so that, it's not quite as annoying. Okay? So we'll do that here in a second. Because I know exactly that that's what you were thinking in your head.
Definitely.
Yeah. So we'll input int2.dat right here, which is a file that should open. 853 values were read from the file int2.dat. The average of those was 494.37. Hey, I don't know. I don't actually have the answer here, but that seems reasonable. So we'll go with reasonable.
I'm also not one to count 853 values.
Well, I got bad news for you, Alex. This is your homework now.
Okay. Hey, at least if I'm not actually having to do the counting, I don't care.
No, okay. Let's scroll up and let's just make some improvement really quick. We are going to throw this into a do while loop. So let's do that. Do. And let me just grab basically all of this and put it in here, into this do. while, not dn. Oh, it's not dn, it's in file here. Listen, I'm trying to be consistent, but you know, sometimes it's a little hard. I hope that you understand, okay? Okay, let's see what that change did for us really quick. That's already much better, right? The only thing that I don't like is I want to change this. I want to say if not in file. I want to take this output message and put it right here. So then, if they didn't input it correctly, we'll see out the file you specified, and then the name was not found. And then please enter the name of the input file. And we'll just keep looping that, right? And now, so this is going to be a bit of a change, so be careful if you're going to make the same modification that I'm about to do. But what I'm going to do is I'm going to take all the contents of this else block, because we don't need the else block anymore, right? We don't need this if else structure, because if the file is not found. No, we're guaranteeing that we're going to find the file because we got the user stuck in this do while loop until we successfully find the file, right? So I'm going to cut this out. And I'm going to come up here and I'm just going to select all this, delete it, and then paste it back in. And then if I come here, I'm fine with that. It says the file was found and all that stuff. Okay, so let's double check that this still works. Okay, still seems to work the same. So our do while, and don't forget your semicolon at the end of that while. It's a little bit different than all the other loop structures. Any questions about this one? So we're doing a couple of things here. Just want to take note of before moving on. Well, we have our single value returning function. We have a sentinel value. A sentinel value, if you're going to use a sentinel controlled loop, generally doesn't change. That's not exclusively true, but it generally doesn't change. So you should declare it as a constant so that it doesn't change. You have a loop that allows us to, our do while loop, which allows us to validate user input now. So I hope that I see a lot more of that. That's going to be exciting. So we're making the user repeatedly input the name of the file that they want to open until they successfully open one. And then we have our event loop, which is a end of file loop. Well, it's not. No, it's not an end of file loop. Excuse me. It's a sentinel controlled loop. But we are reading from a file until we get a sentinel value. And then we call our function with our results to get our results. And then we just display the summary. Okay. There's one thing that I'm just now realizing that is kind of a problem with this setup, with our loop setup in particular. Has anybody spotted anything kind of weird about this setup? What if, let me just say that, what if that's our file? So there is no -1. There is no sentinel value. What if we wanted to either read to a sentinel value or until you get to the end of the file. It's kind of a mishmash of a sentinel loop and an end of file loop. What is the one change we would need to make for that to happen?
Would you have to do while, or like not till sentinel value, and then you'd have to do or not in file?
Oh, okay. Yes, I like what you're saying, and you are so close. So what you are saying is or in file. Because that's what we would do is we would say while d in, do a loop body, and then read the next value from the file, right? But if this
Yeah.
is an or, that's not exactly what we want, right? Because what you're saying is if this is not the sentinel value or it's not the end of the file. So one of those is going to be true. Even if the sentinel value does come up, well, there's still more values to read, so we'll just keep looping, which is not
Right.
what we want.
Yeah.
So what we really want here is an and statement, right?
Yeah.
So what we're saying is, as long as while our num is not our sentinel value, and we're not at the end of the file, keep looping. So if I made the change to this file, so let's open this and let's just run it again. Let's see if it gives us a bigger number, because it should. Oh yeah, just a little bigger. So if I come back in here and I put back in my -1, so my sentinel's back in there. So my value should go back to what it was before, because we should stop once we reach our sentinel value. And it looks like it did.
I just gotta ask, who took the time to type in 999 three-digit numbers?
Nobody. Rand. There is a function within C++ that allows you to easily just generate a random number on the fly. So
Ooh, wow.
you
Nice.
know how to
Almost random numbers?
pseudo random number. Okay, now you're getting into theory, and hold on, I gotta stop this video before we have this conversation. So before we go off the rails here with our discussion, anybody have any directly pertaining question before I stop this recording? Okay.